All right, before we go any further, let's talk a little bit about the gear setup and what all the components are. The purpose of this video isn't to not only just show you the procedures for putting it back together, but also kind of explain what's going on here. So, okay, we already know that this is the inner pinion bearing. We push that on. We're happy with the shim, which resides right below it. And then the next thing that would go on is the crush sleeve. Okay, and then on top of that is the outer pinion bearing, which goes like that. And you can see the outer pinion bearing, when we put that flange on, this is the inner race of this bearing is what's going to crush this down. Okay, and then on top of that, we have what is referred to as an oil slinger. I think that's kind of a bad name because it doesn't sling oil at all. And I'll explain the purpose of this here in a minute. And then, of course, the seal that gets pounded in to the differential, and it's going to reside like that. And then, of course, the flange goes on top of this with the pinion nut. Okay, so first of all, let's talk about oil slinger. Why do we need this? It doesn't sling oil, and it's not a shim. I've heard it referred to as a shim before. It doesn't really shim anything. So what's the purpose of it? Well, when the gears are spinning fast, if you look at the rear differential, you'll see that there's kind of a little tunnel where the oil comes back up here to lubricate this outer pinion bearing. And so when it's going real fast, it can create a high pressure. And so the purpose of this is to prevent that high pressure oil from pushing against this seal here and then causing a leak. So really what this is doing is shielding the pinion seal from the high pressure oil to prevent leaks. So it resides right here, and that goes here. And you can see that with that right up against the seal, that it's going to protect around the seal here to prevent anything from leaking. So really it should be called an oil slinger shield. And so that's the purpose of this. Important, if you don't put that in, you're likely to end up with a leak in the seal here. Okay, so the crush sleeve. Why do we need a crush sleeve? What does that do? Well, when you put this pinion nut on, there's two different settings that we need to worry about. One of which is, of course, the torque for the pinion nut. And if you'll notice that in the instructions, there's no torque setting for this. The reason being is this crush sleeve is what creates the torque setting for the pinion nut. It's going to take so much torque to start crushing this sleeve down. So we don't worry about the torque setting on the pinion nut. What we do worry about is this sleeve gets crushed down, these two bearings get closer and closer together. So it's getting squished into that housing there. And as it gets squished, it creates what we call preload. And that's the resistance, the turning resistance of this pinion in the housing there. And if it's too loose, you could have some play. If it's too tight, you're going to create a lot of additional friction. The spec on it, oh boy, I'm not going to remember it exactly, but for used bearings, it's something like 10 to 20, and for new bearings, it's something like 15 to 29 or something like that. I'll look it up later and let you know when we put it back into the car. We're going to reuse these bearings, so we're going to use the lower preload on it. The reasoning behind that is the new bearings have a higher preload because the thought is they're going to wear in and break in a little bit, and that preload will diminish over time. So that's the reason for the two different preloads depending on the bearings that you use. So, okay, is there an alternative to a crush sleeve? Yes, there is. You can get a solid metal spacer here. And the setup for that's going to be a little different. Basically, the solid sleeve would come with some shims, and you would basically reassemble this, and then you would have a torque setting for this because the crush sleeve isn't going to determine the torque setting, so it's probably around 200 pound-feet or something like that. And so anyway, you would put this on, and then you would measure the rotational or the preload. And if it's too much, then you would take some shims out. If it's too little, you would add some shims. So it'd be a little bit of playing around to get it set. It's definitely more difficult than the crush sleeve. So what's the advantage to that? The advantage is if for some reason you ever have a seal that goes bad, you have to be real careful when you reassemble it because this can only be crushed one time. If you crush it any further, the preload is going to become too high. So anyway, when you take this nut off and then pull the seal out and then put it back on, the fear is that, you know, you start ramping this down and then you get to the point where it starts to crush the sleeve more, and now your preload's too high. Whereas if you used a solid spacer, you would just go to that torque setting. This is never going to compress because the solid spacer is not designed to crush. So you'd always have the proper preload. So it would make it easier to swap out a seal later. And I've also heard that if you're really rough on them, if you're off-roading or maybe drag racing, putting, you know, 1,000 horsepower to it, that the crush sleeve could potentially get crushed a little more. I'm not sure about that, if that's true. I've never seen a problem with a crush sleeve, but this is by far the easier way to go, at least initially. So anyway, that's how the rear end is set up on one. One other quick note: if you did decide to go with a solid spacer, the way to attack it, I think, would be to take the old crush ring off and then measure the thickness of it, and then find some shims that would go along with the spacer, so it would be equivalent to that. At least that would be a great starting point. So one more point, just to make it really clear. Without the crush sleeve, if you were to take this pinion nut and then put everything down to around 200 pound-feet, which is what's required by this pinion nut, the preload would be so high on these bearings that it wouldn't even spin. So again, this is the way to provide a minimal amount of force between the two bearings while still having a lot of torque on the pinion nut.